All right, hello everyone. This is the R session for 27th of February 2018. We're gonna go over a few things. So it's gonna be a short session because there's only a few things that you need for the homework regarding R. So it's just how to multiply vectors or add vectors, how to calculate the expected value, and how to calculate the variance and the standard deviation. So first things first. So let's say we have a vector like this. So this is a vector 1, 2, 3, right? I can also do this, which gives me the same vector. So these two vectors should be the same. So if I type v1, I get 1, 2, 3. If I type v2, that's also 1, 2, 3. So that's just a shorthand we'd use. Now, if you want to take the sum of the vector, that should be pretty easy. That's just sum of the vector. You can also multiply vectors if they're the same size. So for example, because both vectors are of length 3, I can multiply them together, and I would get 149, which makes sense. I can also take the sum of the multiplication to give me 14, which should be 9 plus 4 plus 1. Now, why this is useful? Because that's what you need to do when you're calculating expected values, right? So, for example, let's say I'm rolling a die, right? Let's say the die has 6 sides, so labeled 1 to 6, right? Okay, so let's say that the probability of getting each side of the die is 1/6, which means that if I want to take the expected value, if you remember, that would be 1 times 1/6 plus 2 times 1/6, etc. The way I do this, I just take dice and multiply it by 1/6, and I get the elements of the vector. To get the expected value, you have to sum. So if you remember, the expected value is the sum of each event that can occur times its probability. So that would be 1 times 1/6 plus 2 times 1/6, etc. And if you take the sum, what should I get for the sum? What is the expected value of rolling a die? It should be 3.5, right? Makes sense, right? Because it's 1 through 6 and they're all equal, so it should probably be something in the middle, which is exactly 3.5. So if the events have other probabilities, for example, let's say that I'm trying to play the lottery, for example. Let's say that I can either win $1, $2, $3, or $4, and let's say that this is the probability of winning. Let's say the probability of winning $1 is 0.1, or $2 is 0.2, etc. So what I can do to get the expected value is, again, I can take the sum where I multiply both things. So first, to see how it looks like, is this is how I multiply two vectors. This is what I get, right? 0.1, 0.4, 0.9, 1.6, which makes sense. So to get the expected value, I just have to sum all these things here. And to sum that, I get 3. So I guess if you're playing the lottery with these odds, and I don't know, these rewards, then the expected value is 3. So you should expect that in the long run you would win $3 basically for every time you play on average. So that's the expected value. This should be useful for your homework. So the other thing that you need to do is you would have to take you'd have to calculate the standard deviation for the variance for some variable. So if x is my variable, and again, x takes values 1 to 4, and the probabilities are again 0.1 to 0.4. So I can find the mean, which should be 3. That's fine. And now first I take the square deviations. That's just this this formula. So it's for every x, I subtract the mean first. So let's see how that looks. So that makes sense, right? It's 1, 2, 3, 4 minus 3 for each of the elements. So I get -2, -1, 0, and 1. And then these I have to square. So to square these, I just have to put them in parentheses and type square. I can't seem to type. Oh, mine's bugged. All right, I'll just have to run the command. So if you square these, you get the square deviations, which makes sense, right? 4, 1, 0, 1 as a square. And finally, I have to multiply the square deviations by its probability. again, I know we're multiplying by its probability. You just have to remember this, and that's how you calculate the variance. So the variance is when you sum all of the square deviations times their probability. And if I do that, I should get the variance. It's actually 1, just by coincidence. Usually not a nice number. It's something like 0.345 or something. It's usually not a nice number. But in this case, it is a very easy number to remember. And the standard deviation is just the square root of the variance. You just write square root of whatever you're interested in. So that should be, the square root of 1 is 1. So that is actually mostly what you need for this homework, and there's nothing else that you're required to solve this. There's actually more. I guess it's more theoretical for this homework than R, but this is mostly what you need for the homework. Are there any questions? So the problem would ask you, for example, what is the mean of the, let's say I am trying to, let's say you have a problem that you're playing the lottery and you can either win 1, 2, 3, or 4, and then you have the probability. So the problem would say, for example, actually let's make it more interesting. Let's say that you can either lose $1, lose $3, or win $2 or $4, and then you have probabilities of each of those things happening. So for example, one useful thing would be, what is the expected value? Well, the expected value is, I have to sum up what is the probability of getting each thing. So for example, I can either lose $1 with probability 0.1 or win 2 with probability 0.2, etc. So if I multiply those two together, this is what I get, but I have to sum these up and then I'll get the expected value. So that will be the mean, which is the same. So the mean and the expected value are the same thing, which is 1. So in this case, again, interestingly, you're on average expected to win $1. So for these probabilities and these outcomes, so you either lose $1 or $3 with these probabilities, or win 2 or 4 with these. This is the expected value. So some of the problems would ask you for that. The other problems, well, actually, usually the same problems would ask you for the standard deviation. Now the standard deviation is a bit more harder to calculate. First you have to calculate the mean, which is this line. So first you run this line, and then you'd have to calculate the square deviations, which is just what basically we call x. When you take the vector x, you subtract the mean, and then you just square the whole thing. So that would be the square deviations. So in this case, because we changed the x vector, it should be something else. So actually, just a sec. Oh yeah, because we changed the mean. Now the mean was 1. So basically x minus mean is something else now. So it was -2, -1, 0, and 1. Now it's these numbers. And now if you square these numbers, you get different square deviations. And then so the variance is just taking the square deviations times the probability and then summing it. So just that's the definition of the variance. If you look at the mathematical equation, and if you do that, you get the variance, which is, well, 9 in this case. This makes more sense, right? The variance measures how much our vector, our x, varies. So before we had x was between 1 and 4. Now x is between -3 and 4, right? See, now the range of our vector is different. Because it's larger, then it means that the variance is going to be larger. So now the variance is 9, and that means that the square deviation, the standard deviation should be 3. Yes, luckily. Does that make more sense? Yeah. Are there any other questions? Are there any questions not related to this week's homework, but are in general? Yes, I think so. Yeah. Yeah.
On the first exam, one of the questions had a list of numbers separated by commas, and they wanted us to check for the outlier, and we were supposed to make a histogram or a box plot to show that
Oh, you would just need to, you can just plot the numbers. So for example, let's,
I know it's really simple.
no, you can just, so for example, if you plot, so when you're plotting, you're giving it x coordinates, let's say 1 to 10, and you don't even have to do this, and let's say the y coordinates are 1 to 10 but squared. So this would be 1 to 10 but all of them squared. So let me just run this so that you can see. So this would be the numbers. No, actually that's wrong. I should put parentheses here because yeah, okay. So this is 1 to 10 but the squares of each number. So for example, I can plot this, and this is how it would look like. Wait, you can barely see. Okay, so this is what my plot is, right? So actually I don't even have to write this. It'll automatically do 1 through 10 if I don't say it will. So it's literally the same thing. Now, if you want to find an outlier, if your data is, for example, C123 minus 1, 256, 1, well, I can just plot my data. So I can plot this data, and this is immediately what I get, right? So you can see the outlier on the graph.
Right.
So it's all of the values around here, and then the outliers over here. You can also do a histogram, which would give you mostly the same thing. So if I do a histogram, you can see that the numbers are here, but then there's one outlier farther to the right. So either a plot or a histogram would work in this case.